Imagine standing in the heart of the Sahara Desert. Endless dunes stretch as far as the eye can see. The sun blazes down mercilessly. The wind whispers over dry, cracked soil, carrying only the dust of centuries-old sandstorms. Water, something most of us take for granted, is almost non-existent here. But what if I told you that German engineers have managed to produce millions of liters of water right here, in one of the harshest environments on Earth? Yes, you heard that right. In the middle of the Sahara, a desert where water is worth more than gold. These scientists have invented a technology so advanced, it seems almost magical. Millions of liters of water, pulled straight from the air, stored, and distributed enough to transform lives, agriculture, and even the climate of entire regions. The Sahara Desert spans over 9 million square kilometers, covering parts of 11 countries. Yet it receives less than 100 millimeters of rainfall per year. In some regions, decades pass without a single drop of rain. For millions of people living in and around this desert, survival depends on tiny underground aquifers or seasonal wells. Crops fail, livestock suffer. Entire communities struggle to access something most of us consider basic: water. Climate change is making it worse. Rising temperatures and prolonged droughts are turning arid areas into lifeless wastelands. The Sahara is not just dry, it's a ticking time bomb of environmental collapse, threatening not only the local population but also biodiversity and the global climate. Engineers have developed unbelievable technology that turns desert air into drinking water. But how does it work? At its core, the technology uses a combination of solar energy, atmospheric water generators, and advanced condensation systems. Imagine this, even in the driest air, there is moisture, tiny water molecules floating invisibly. These machines capture that moisture. Through sophisticated cooling and condensation processes, the water vapor becomes liquid water. Some systems rely on solar-powered fog collectors. Massive nets are set up across strategic points. When humid air passes through the nets at night, fog droplets condense into water, which is collected in tanks. One night can produce thousands of liters. Other systems use atmospheric water generators powered entirely by solar panels. They can run continuously, sucking moisture from the air during the day and night, filtering it and delivering clean, potable water. The most advanced installations combine fog harvesting, condensation, and solar-powered desalination to maximize output. They can operate in extreme heat with minimal maintenance and produce millions of liters of water annually. Now, the scale of this operation is astonishing. In some German projects, a single installation produces up to 10,000 liters of water per day. Multiply that across several units spread over a desert region, and suddenly, you have millions of liters flowing where none existed before. This is not just about numbers, it's about transforming lives. Villages that once depended on distant wells now have access to clean water within minutes. Crops grow where the soil was once barren. Livestock thrives. Even local microclimates are improving because moisture in the air contributes to tiny changes in humidity, supporting plant growth. German engineers are also exploring mobile water units, which can be transported by truck to remote communities. In emergency situations, droughts, famine, or refugee crises, these units can save lives immediately. The potential isn't limited to the Sahara. Other deserts like the Gobi in Asia, the Arabian Desert, and even parts of the American Southwest could one day use the same technology to secure water for humans. Agriculture and industry. Of course, there are challenges. Producing water in a desert is not cheap. Setting up large-scale installations requires investment, careful planning, and local cooperation. Maintenance is essential. Machines exposed to sandstorms and extreme heat need protection and frequent inspections. Energy efficiency is another concern. While many systems rely on solar power, desert temperatures and weather conditions can affect performance. Engineers are constantly optimizing designs to make production as cost-effective and sustainable as possible. Yet despite these challenges, the future looks promising. Researchers are experimenting with self-sustaining units powered entirely by renewable energy, capable of producing water even in extreme desert conditions. The dream? Entire deserts turned into oases of innovation, providing not only water but also food, electricity, and even a buffer against climate change. What we're witnessing here is human ingenuity at its finest. Turning desert air into millions of liters of water sounds like science fiction, but it's real, and it's happening right now. Imagine a world where no place is too dry to sustain life, where innovation conquers scarcity, where deserts become sources of life instead of wastelands. Could German technology be the blueprint for solving water scarcity worldwide? Could this be the first step toward a planet where no human has to go thirsty? We don't know yet, but one thing is certain. The Sahara Desert will never be the same again. What do you think? Can this technology change the future of water? Let us know in the comments below, and don't forget to subscribe for more incredible engineering stories from around the world.